Good morning. Can you all hear me? Good morning, everyone. Can you all hear me?
Good morning,
Good
sir.
morning, sir. Yes, sir. Good morning, sir. Yes.
Okay, thank you. Any questions from last time's examples, clarifications, anything that you need from previous day examples? Any questions? Right. Just to recall what we have done at the last on the previous day, the rule of logarithmic functions, right? Especially the exponential function. Suppose if the exponential function is given as e to the power x, all right? Then the derivative dy by dx can be given as e to the power x into dx. suppose let's say the power is u, right? So if the power is u, we could say the derivative of y with respect to x is given by e to the power u into du by dx. So this is the formula that we adapt. So we took a couple of examples. Suppose let's say y is e to the power x. Derivative of that is given by dy by dx is equal e to the power x into derivative of that, right? That is 1. So the answer is e to the power x. Suppose let's say y is equal to e to the power x plus x square plus 1, right? So the derivative dy by dx is given by e to the power 2x plus 1 into derivative of this, that is 2x. So the answer would be 2x into e to the power 2x plus 1. Right? So that is how you get the derivative of that. Anybody would like to ask any questions on the homework or any other examples? Suppose, let's say, if you have given equation or the function e to the power x into x square plus x plus 1. So how to handle this as an example? We could consider these two components, this as u, this as v. You can recall your dy by dx formula. Can you remember? Dy by dx is equal u into dv by dx plus v into du by dx, right? So that is equal u is e to the power x into derivative of v, that is 2x plus 1 plus v, that is x square plus x plus 1 into derivative of that, that is e to the power x into 1. So ultimately, your answer would be e to the power x, right, into 2x plus 1 plus x square plus x plus 1, right? So that could be expanded further, e to the power x into x square plus 3x plus, okay? Any question? Right. We can continue. Any clarification question? If you have any questions, I would be able to answer. Right. Similarly, if you have a condition like this function, again, you consider these two components. This is as u, this is as v, u and v, right? So dy by dx, again, put it into the same formula, u, that is 1 over x, into derivative of that, 1 over x. Okay? So plus ln x into 1 over, sorry, derivative of that. Derivative 1 over x, what is that? We can write this as x to the power minus 1. Good. So x to the power minus 2 divided by how to differentiate x to the power minus 1? Anyone? If you differentiate this is minus 1 into x to the power minus 2. So this is also x to the power minus 1, right? Into 1 over x plus ln x into x to the power minus 2. This is becoming plus. This becomes as minus 1. Minus 1 into plus. This is a minus, so ln x. This is how it works. So here we could say this is 1 over x square minus ln x into 1 over x square. So that is equal 1 over x square, take it out as a common term, 1 minus ln x. That is your answer, final answer. Any questions? Sampath, can you mute it?
Okay, sir.
Others also, please mute it. There are 3-4 people have not muted your mics. Please mute it. Otherwise, it is disturbing. Yeah. Any questions? Any special questions that you need to ask before we move to further on differentiation? Right? Any questions? If not, we'll move further. Right? Implicit differentiation. What is implicit differentiation? Let's say a function. This is how we say this is a function called as implicit function. So this is a function called as implicit function. All right? This is an implicit function. Function of xy is equal 0. Similar to, have you seen a function like this earlier? Anyone? Have you seen any function like that? Yeah? Anyone? Yeah. The circle function. It's a kind of implicit function. Circle function. Yes. It's an implicit function. 24101 Vikramadinge. Can you mute it? Yes. Right. So, first of all, what we meant by implicit function. Let's understand what is implicit function. So, implicit functions, we can define it as dependent variable dependent variable has not been given explicitly in terms of independent variable. So this is what the definition says of the implicit function. So what is the dependent variable, anyone? Here we have two variables, x and y. You will be learning this in statistics also. What is the dependent variable? Anyone? What is dependent variable? Right? What is dependent variable? Anyone?
The variable, which one we going to change manually?
Yeah, but here, by considering two variables, here we have two variables, no, x and y. So, which could be the dependent
X.
generally, which could be the independent.
X dependent, Y independent.
Are you sure? So this is how we write the function. Earlier I mentioned this is how we write the function. This is how we write the function. Y is the function of x. So y is determined using x. So who is dependent? Who is dependent? Y is determined based on the value of x. So who is dependent?
Y.
Y.
Y is dependent. So always this is how we take it up, right? So don't forget that. When you say in a function in general, this is kind of a fixed rule where if you have xy variable, usually y variable is the variable which we call as dependent variable. Independent variable, then here we have only two variables, you see x and y. Okay? So the next one is definitely independent variable, that is x. So now we understand the concept dependent variable has not been given explicitly in terms of independent variable. We will see what it is. That means we cannot define the dependent variable only in terms of independent variable. Only in terms of independent variable. That is what it meant, right? So how it could be? For example, there are a couple of examples for independent variable. Sorry, implicit function, right? So here, if I want to take y square, this is 4 minus x square. Y is square root of 4 minus x square, isn't it? So that means y can take two values for a given x. So this is a implicit function, not directly found with the y value. So this is how we call it as two-valued function. Can you remember? We mentioned about this two-valued function when we discuss about the function. Two-valued function. Right. Another example, x square plus 2xy plus y square or y to the power 3 is equal 5. So this is a another implicit function. This is another implicit function. Here we can't differentiate the x and y separately. I will show you. This is called as the implicit function. This is an implicit function. How we could find out whether we cannot separate them, right? That we are going to do it. By differentiation, we cannot separate. Let's look at with an example. Assume that y is a differentiable function defined implicitly by the equation, let's say, x square plus y square equals. Assume that y is a differentiable function defined implicitly by the equation y square plus x square equal, right? Finally, dy by dx in terms of x, and so you ask to find out dy by dx in terms of x and y, right? Let's look at how to handle this. The same equation, I can write it as x square plus y square equal for same thing, right? Whether it is y square plus x square is equal for or x square y square. How to differentiate this? Look at very carefully. There's a small concept in differentiating this kind of implicit function. You differentiate first component. With respect to, always we differentiate with respect to x, so that it will become as 2x. Right? You differentiate y with respect to x. It becomes as plus 2y into differentiate that y component, that is dy by dx. Equal, if you differentiate what is on your right side after equation, which is 4, what is the derivative of 4? Anyone?
0.
0. So we can rearrange. We want to bring it in dy by dx form. So that 2y into dy by dx is equal minus 2x. So that 2y, sorry, dy by dx is equal minus 2x divided by 2. 2 will cancel off. My dy by dx is minus x by y. So this is my dy by dx. Can you remember? Our derivative cannot be explicitly defined in terms of independent variable. So look at the previous functions. When you get the derivative dy by dx, it has been given only in terms of x variable, nothing else. It has been given in terms of x variable when you differentiate dy by dx. Now, if you differentiate implicit function, your derivative dy by dx will not be given not only in terms of independent variable, right? But it involves with some level of dependent variable also. That means we cannot separately give them as a explicit function, right? So that is the problem with the implicit differentiation, right? Take another example. Uh, Same concept, x square plus y to the, sorry, y to the power 3 is equal 10. Try this one. 2x plus 3y into dy by 3y square, right? Not 3y square into dy by dx equals 0. So 3y square into dy by dx is equal minus 2x. Dy by dx is equal minus 2x divided by 3y square. Okay, so we could say, if you want, you can cancel off, otherwise you can leave it as it is. Right, I will give 5 minutes. Try this one. X to the power 3 plus 2xy plus y square equal 5. This one. Now we have a multiplicative component, isn't it? X as a sole, y as a sole. Then we have a multiplication function, xy, in the middle. Right. When you can, I will give a clue. This you can differentiate similar to earlier one. This also you can differentiate similar to that. How about this? Because it is a multiplicator. X and y are multiplying each other. You apply the rule. This is V. Now can you try? I will give you 2 minutes. Try. Right. Anyone got the answer? Anyone got the answer? Right. We will do it together. I will give a similar one after doing this. First, we'll have to differentiate this. So that is in a normal way 3x plus. Now you handle this u and v. U, that is 2x into dv by dx. So if you differentiate y, it is dy by dx. Plus v, that is my y, into differentiate 2x, that become as 2, plus differentiate that y square, that is 2y into dy by dx is equal to, now we'll have to rearrange 2x into dy by dx, that is plus 2y into dy by dx equal 3x square, which is a minus, right? Plus, which you are taking to the left side, right side, 2y. Any questions? Any mistakes? You can ask me. Now we say dy by dx is a common term, 2x plus 2y is equal minus 3x square plus 2y. The last step is dy by dx is equal minus 3x square plus 2y, whole thing divided by 2x plus 2y. So that is my final answer. Look at here, as I said earlier, look at the derivative dy by dx. It is given not only in terms of x, but also in terms of y. You see, not only in terms of x, but also in terms of y. So that is why we call this as an implicit function. Suppose, let's say I have a function x, y is equal 3x square plus 4x plus 8. If you differentiate this, dy by dx is equal 6x plus 4. Now you see this dy by dx is given in terms of only one variable, which is x, independent variable. Right? So these functions are not implicit function. These functions are explicit function. This is an explicit function, no problem with that. But this function is an implicit function. Clear? Where our derivative dy by dx cannot be expressed only in terms of x variable, that is independent variable. Right, I will give you one more examples before we move to other section. I think we have some examples in our tutorial, right? X into y to the power 3 plus x square y square plus 3x square minus 6 equal 1. Can you try this one? Anyone got the answer? You have to come up with the answer. You see here, this is U and V. This is again U and V. So this is no problem. So first step, if you want, you can take all the constant to the right side. X y to the power 3 plus x square y square plus 3x square equals 7. Right? Without that also you can do it, but that is easy. Right. Then you differentiate this, right? U into V 3 y square into dy by dx. That is the derivative of y to the power 3, right? Plus it's going to be a big one, plus y to the power 3 into 1. Because if you differentiate x, it is 1, plus differentiate this, x square plus y square, x square into 2y into dy by dx, plus y square into 2x, sorry. So we have done that also, plus differentiate that, 6x is equal to 0. So it's a big one. Now we'll have to rearrange it, right? So 3xy square dy by dx plus 2x square y into dy by dx. Keep those two on the left side. Take the rest of the things onto the right side. So that is minus, I'll start with the x component. Right, 6x plus 2xy square plus y to the power 3. Okay. Now we take the common term dy by dx. 3xy square plus 2x square y is equal minus 6x plus 2xy square plus y to the power 3. So that dy by dx can be written as minus 6x plus 2xy square plus y to the power 3, whole thing divided by 3xy square plus 2x square y. So that is my answer. Any questions? Any questions? Ahmad, any questions?
No, sir. Thank you.
Any others having a question? Ranatunga? Any questions? Or see some names? Mendis, any questions? I would like to ask few questions from the people who have already logged in. I see some of you are having a registration number starting from 20. Some of you are having a registration number 23. Actually, why? Why you all are following this? Because, yeah, 20007. Who is that? 20216.
Hello, sir. I'm Imanka from. Hello, sir.
Yeah, yeah.
Sir,
go ahead.
I am Imanka. I'm 2007 PDN, and
Okay.
I missed the exam and for the first time. Then I appeared the second time also, but I missed the.
Did you follow the program earlier?
Yes, sir. For the second time, I have logged and passed the exam, but I have.
No, I'm asking whether whatever the first time or second time, did you follow the lecture series?
Yes, sir. I
Ah,
have.
then why you
Then.
are following again the lecture series? No point of following again, isn't it?
Okay, sir.
No, I mean you can follow, but is there any need for that? Because already the same thing will be taught here as well.
Yeah,
Hmm?
but I thought that it's good to
Follow.
participate these lectures also. That's
But
why
but you have other courses, right?
sir, I have already completed all the
Ah,
subjects, and
correct.
that's why, sir.
Okay, okay. So that is okay, fine.
I thought that, sir, I want to pass all the quizzes on this time also. That's why I connect to these lectures also.
Okay, good. How about others? 20216, 22513, 23055. A lot of people who are registered in the previous years are following this course. Because when I met last week the director mentioned about this. That is why. A lot of people who are registered earlier in the last year and even previous year are following. That is all. What is the reason by others? 20216, 513.
Sam Tilakshi.
Yeah.
The first time, unfortunately, I have repeated subject. So then I hold my degree in my personal reason. So then I think so. I hope to face this time to exam.
Yeah. What about other courses? Have you completed with other courses?
Yes, sir.
You completed?
Yes, sir.
Interestingly, yeah. Because very interestingly, this particular courses, basic statistics and calculus, we give this knowledge at the beginning to cope up to the other programs as a prerequisite, right? But what is happening is after completing almost all the courses, you all are doing this. That is the bad part of it, right? So, I mean, purpose is not completed. The purpose is totally irrelevant, isn't it? Madhavika?
Sir, this is the first time I got the semester. I missed last semester. Yes.
You are starting only, even though you have registered earlier.
Yes, I was not in here, so
Okay,
I
right.
missed the first
Right.
time.
Okay. So that is understandable. Yes. If you are doing, if you have started, even though your registration is older one, even if you start your degree program, that is fine.
Hello, sir.
Madhumal? Yeah.
Same thing happened to me, sir. I enrolled the course after this course ended.
Mhm. Okay.
My other subjects are all completed now, but I missed that
Why
maths
why you
part.
couldn't follow last year? Because your registration number says 2-2, right?
Yeah, I missed that one also, sir.
Hmm. Yeah.
So I enrolled this time.
Okay, good. Right. That is true with Pilapitia. So many are there.
Hello,
I
sir.
could see. Yeah, yeah,
Sir, I am Pilapitia.
yeah.
Sir, I have completed my mid-in last year, but I
Uh,
couldn't face for the end exam.
uh.
Therefore, I joined here. Sir, can I carry on that mid-exam marks?
No, that will be independent from what we are, because that will not carry here. Because last time this was taught by two people separately, because we have divided the boards so that if you are following fresh, then follow through all these quizzes, and there will not be any midterm, because normally we don't give any midterm for prerequisite.
Okay, sir.
Right. Midterm is not, because normally midterm comes when the course is spread out through the semester, because
Okay,
that
sir.
is easy. Otherwise, we cannot give a midterm where everyone has to be brought down here within short period. So midterm is not possible.
Okay,
Right.
sir.
Okay. So everyone has some reason to follow. That is fine. No problem. Have you gone through the timetable, prerequisite timetable? Yes or no?
Yes,
Huh?
yes,
Yeah.
yes.
What are, yeah. When are we finishing our last lecture?
4th
4th
January.
of January, right? Huh? Isn't it? Exam?
5th of January.
Okay, right. So everybody should know that the exam will be on ground. Exam, whether it is statistics or mathematics, it is on ground, right? I don't know about statistics. Maybe Samit sir will inform you regarding the exam. Mathematics, it's a open book exam. Open book exam. Right? Open book, but there's a restriction. What is that restriction? You can bring 2 A4 sheets. Because if you start bringing all the material on the day that you are sitting the exam only, you start turning up the pages where exactly the topic is, right? So write down whatever you want, anything within 2 A4 sheets. Clear to everyone? So you can bring any material with the 2 A4 sheets will be allowed.
Thank you, sir.
Okay, 2 A4 sheets. So that means 4 pages. You can contain anything as you like within 4 pages of A4 sheet. You can write anything as you like, formula, rules, or whatever it is, you can bring it, right? And you are allowed to bring calculator also, non-programming calculator for the exam. Right. Any clarification? Right. Okay. Right. Another example on this, we did the example, am I right? Yes, we did. Another example on, let's say, square plus y square whole thing to the power 3, right? Minus 8x square equal 8x square y square. This is also another example. How we can rewrite this? We can rewrite this x square plus y square to the power 3 minus 8x square y square is equal 0. So from here we can consider. All right. Somebody has given written a big letter. Let's see. Right. So how to handle this? One thing is you can expand this if you want. Otherwise, apply the chain rule. Apply the chain rule. So if you apply the chain rule, 3 into x square plus y square, whole thing to the power 2. Differentiate this, right? Into 2x plus 2y into dy by dx. It's a big one. Minus the rest, this part. That is 8x square into 2y into dy by dx plus y square into 16x is equal to 0. Am I right? Derivative of that, y square, 16x, yes. Now we can bring it into dy by dx form. We can expand it, no problem. Right? Any questions? Right. So that is about the implicit functions. Implicit functions. Right? Let's move to further on derivatives. Right? Trigonometrical functions. Trigonometrical functions. You know, trigonometrical mean sine, cos, tan, etc. Right? First function, rule. Suppose y equal sine u. The derivative dy by dx is given as sine u into du by, cos u into du by dx. So this is the rule. If it is a sine function, this is the right. let's say y is equal sin x. dy by dx is given as cos x into derivative of x is 1. So that is actually cos x. Anyone are allowed to ask questions? No problem. Whatever the question, you can answer relating to relevant topics. So that will indicate you that you are learning, right? So if you have some gray areas and non-understandable areas, I'm repeating this every time, so you can ask questions. All right? Any questions? No problem, because I don't see you, what you are doing, what you are, how you are behaving, that I don't see from here. But from your point of view, I have opened up my video, so you know what I am doing, right? So if you have any specific questions relating to different topics, ask. Don't keep quiet. Any questions can be answered, right? Right. Let's say y equal sine 2x dy by dx is given as cos 2x. That is your first step. Then you differentiate that component, that's 2. So the answer is 2 into cos 2x, right? Another example, y equal sine x squared. This is not same as sine square x. Sine square x is something like sine x whole thing square. So if you differentiate this, dy by dx is equal cos x square into differentiate that, that is 2. So you can write it as 2x cos x square. Clear? Right. Y equal sine square 2x or sine square x. So this is, as I said, it's same as sine x whole thing square. Can somebody give me the answer how we can differentiate this with respect to x? Anyone?
Differentiate the sine x value and
And pardon? Once again, Birudan.
first differentiate the sine x, sir.
I need the answer.
Square the value.
Birudan, I need the answer.
Cos x squared.
Start with differentiating.
Cos 2x.
2x.
Cos 2x.
Huh? Cos 2x.
Answer.
So I said this is similar to sine x whole thing square. Now think it
Sine 2x.
sine 2x. Where do you get this 2x? Where do you get this 2x? What is the rule that we can apply here to differentiate? Can you recall the rule what we have learned last week?
Chain rule.
Yes, chain rule. Chain rule, yes. So what does, according to the chain rule, tell me what is the answer?
2 sin x cos square x.
2
sin x cos square x.
Yes, 2 cos squared x. Difficult. So this 2 is coming as in front, which is power, right? 2 into sin x, whole thing to the power 2 minus 1. Do you all agree? That is the first step. Then you differentiate what is inside the bracket. If you differentiate sin x, it becomes as cos x. Isn't it? So if you rewrite it, 2 sin x cos x. Do you all agree? Yes or no? Got it?
Yes.
Right. Try this one. Y equal sine square 4x square. Try this. I will come in a minute having cup of, glass of water. In 2 minutes, we will meet again. But you come up with the answer. Right. What is the answer? Anyone? Apply the chain rule. If you apply the chain rule, dy by dx is equal to sine 4x square into 8x. Sorry, Anyone? Anyone? What is the answer? This is similar to that. 2 sine 4x square to the power 1, so we don't need to write, into cos 4x square, right? Into differentiate that 8x. So you see a big jump. So we could say 16x sine 4x square into cos 4x square. Any questions? Right, one more. Couple of more. Y equal, let's say sine ln x. Y equals sine ln x. Differentiate that function. Differentiate that function. Anyone?
Cos ln x over 1 over x.
Cos
Cos ln x into 1 over x.
good. Okay, so that could be written as cos ln x divided by x. Right? So likewise, you could perform it. Different rules coming again and again. Another one, last one could be sine ln x square. Try this one. New one.
Cos 2 ln x into 2 over x.
Cos. Yeah.
2 ln x.
Cos 2.
2 ln x into 2 over x.
Something like that.
Yes, sir.
Right. We will see. Right. Differentiate that dy by dx. Ln x square. So that is your first step. Right. Then you differentiate as it is into 1 over x square. Then you differentiate this x square. That is 2x. Right? So here 1x will cancel out. So you could write as 2 cos ln x square, whole thing divided by x. So Munasingh has said this 2 has to come at the beginning because it is interrupting, because this cos is only for ln x. Got it, Munasingh?
Yes, sir, got it.
Yeah, something wrong here. Right? Okay. Right. Okay, good. Right, now we will move further. We have seen only the derivative of sine. Let's say how to differentiate the function y equal cos dy by dx is given as minus sine u into du by dx. This is the next rule. Huh? I don't know the numbers, but next rule. But second rule in trigonometric functions. So if you differentiate cos x, if you differentiate cos x dy by dx is equal minus sine x into 1. So that we write as that. Suppose y is equal cos 3x. Differentiate that, become as dy by dx is equal minus sine 3x into differentiate that, that is 3. So minus 3 into sine 3x. Clear? Right. We'll do a couple of more examples in cos. Y is equal cos 4x square. So dy by dx is equal minus sine 4x square into derivative of that. That is 8x. So you could write it as minus 8x sine 4x square. Right? Y is equal cos square. Yeah, cos square. Let's say 3x square. Differentiate anyone? Dy by dx. Differentiate it. How to write that? Anyone?
6 cos 3x into sine 3x.
Pardon?
6 cos 3x sine 3x.
6
Cos 3x
3
x sine 3x.
sine 3x. Let's see the answer. So I will write my one. 2 into cos 3x square into differentiate cos 3x square. That is sine, which is minus, minus sine 3x square into 6x. So that is equal, I could say minus 12x, right? Into sine 3x square into cos 3x square. Cruz, can you see the difference of your answer and my answer? Understandable or any clarification? The answers are little different, right? How do you get this answer? Right? I will rewrite it again. Y is equal cos square 3x square. So this is actually, as I said, cos 3x square, whole thing square. Apply the chain. Dy by dx is equal chain rule 2 into cos 3x square to the power 2 minus 1, it is 1, into differentiate what is inside. Cos 3x square. Differentiate that. So that becomes as minus sine 3x square into differentiate this compound, which is 6x. Right? So the answer is this. Cruz, you found the places where you missed it, right?
Yes, sir.
Yeah. Any clarification on this? So for your final exams, you will get basically 2 parts. In your final exam, you will get 2 parts, right? In part 1, you will have 15 questions. 15 questions. These 15 questions are similar to this. I mean, that doesn't mean I'm giving all the questions on derivatives. So as an example, get the dy by dx for the above function. So likewise, direct. 15 questions will be direct. You have to solve it directly. Right? Part 2, this is 1 hour. Part 2 is also 1 hour. Part 2, mainly you will have 2 questions with several parts. Right? This is more on application. I will talk about applications. Right? Applications. Right? I'll give some hint how the applications could be implemented using mathematics. Right? In the questions, we'll see. Right. Any questions? Try this one. Y equals sine square x plus cos square x. Anyone? What is the answer? A simple one.
2 sin x into cos x plus 2 cos x into minus sin x.
Yeah. What is the answer? Final answer.
0.
Yeah. Okay. Why 0? Yeah, interesting. Right? Dy by dx is equal to sin x into cos x plus 2 cos x into minus sin x. So this is the derivative of that. Don't ask how it comes. We have already done similar kind of things. Chain rule, right? Right. Now we can write it as 2 sin x cos x. This minus is there. 2 sin x 6. So this is 2 sin x, 2 sin x cos x minus 2 sin x cos x. This is 0. Why it is 0? Anyone? Why is 0? Can you remember? We have seen something like this earlier in the first or second class. What is that? Anyone? That is equal?
Pythagoras.
No, that is equal
One.
sin x
One.
plus
1.
1. So if you differentiate the left side and the right side, it should be equal. If you differentiate the right side of the equation, what is the answer? If you differentiate right side of the equation, what is the answer? It is 0. Similarly, if you differentiate the left side, it should be equal to 0. So that is why it's becoming a 0. So the rules exist, right? Any questions? Right. Let's move further. Our next rule, y equal tan equal tan. The derivative dy by dx is given as sec square u into du by. So this is the. So if you say y is equal tan x, derivative dy by dx is given as sec square x into 1. So that is the answer. Right, we don't spend much on this other trigonometrical functions. Anyhow, let's say we will see what are the ways to find out the derivatives. The next one, y is equal cot u. Cot u is 1 over tan. 1 over tan u is cot u. So that is given as dy by dx is equal minus cosec square u into du by dx. Right? Suppose let's say if y is given as cot x, it's given as dy by dx is equal minus cosec square x. Right? We don't spend that much on cosec and sec. Anyhow, we will see how their derivatives could be achieved. The next one is y equal sec u. Sec u is, as you all know, 1 over cos u. So dy by dx, derivative of that, is given as sec u into tan u into du by dx. By rule, this is how it works. Then, right, if you say y is equal sec x, if you want to differentiate sec x, dy by dx is given as sec x into tan x. The last one, how to differentiate cosec. Suppose, let's say y is given as cosec u. Cosec is, as you all know, 1 over sine. Cosec is 1 over sine. Right? So dy by dx is given as minus cosec u into cot u into du by dx. Suppose, let's say, if I have y equal cosec x, dy by dx is given as minus cosec x into cot x. So you should know how these conversions are when you differentiate different trigonometrical functions. Sine becoming as cos, cos becoming as minus sine, when you differentiate. Sec becoming, tan becoming as sec square, then cot becoming as minus cosec square, then sec becoming as sec and the tan. The last one, cosec, is differentiated, then it is becoming as minus cosec and cot. Right? Right. We don't spend that much of time on other functions, right? Sec, cosec, tan, and so on. Right. Now let's talk about derivatives. Derivatives of an inverse function. Derivative of an inverse function. Right? What is the inverse function? Right? Y equal sine x, sine inverse x. So this is an inverse function. Right? This is an inverse function. What do you mean by inverse function here? If you convert this becoming as sine y is equal to x. Sine y is equal to x. Look at here. These values of x and y. Right? Values of x and y. Here, x has the normal value. What about y? It's in angle, because it goes as angle. Isn't it? Y is in angle. Sine 30 degree. sine 90 degree angle. Okay. So how to differentiate such kind of functions? Inverse functions. All right. Let's start with y is equal sine inverse. So that is the inverse function. Sometimes it is called as arcsine. This is called as sine inverse. Or it's called as arcsine. Sometimes we might have heard about arcsine of x, sine inverse of x, right? So you might have heard about this, the conversion of data. Maybe we will be learning the basic statistics. Sometimes if the data is not normally distributed, we're talking about normal distribution. Sometimes for certain analysis, we need to assume that data is normally distributed. But in certain cases, it's not so happen. Some data, even it is parametric data, it's not normally distributed. All right? Have you heard about normal distribution? Yeah, from the statistics course, those who are following statistics. Have you heard about normal distribution?
Yes, sir, some bell-shaped distribution of the data.
Yeah, Amarasiri, yeah.
Bell-shaped distribution of the data series.
Yeah. I mean, normal distribution. You learned, right? Right. You learn. Yeah, that is what I want. It is a symmetric distribution. It's a bell shape. Those are characters, right? Characters of those distribution, different characters. So bell shape, symmetric, mean, median, mode are lying on the same position. Values are from minus infinity to plus infinity. Those are characters, right? So sometimes for analysis, certain analysis, we need to assume that the data is normally distributed. In certain cases, which is not happen, data may be not normally distributed. So we'll have to force them to bring into normal distribution or we convert it. So one of the conversion technique is using this arcsine. There are other techniques, taking square root, right? Another example for conversion of data. Arcsine, log transformation. Several are there. Right, one of these is arcsine transformation. Right, it is coming in statistics also. Right, how to differentiate this function? So we could write it as sine y is equal x. This can be written as such. Sine y is equal x. Okay. So now we'll have to differentiate this separately, this separately. So you differentiate this sine y, it becomes as cos y into differentiate that dy by dx is equal. If you differentiate x with respect to x, it becomes as 1. From that, we could say dy by dx is equal 1 over cos y. 1 over cos y. Now this is in dy by dx form. This is in y form. No, we cannot give this in y form. We'll have to give it in x form. So how to do it? What is the step?
Sir, how did that step arrive?
Which one?
Sine y equals x.
Sine
Y equals x. How to write that?
This is how it has been converted. This is the original equation. Y equal arc sine, sine inverse x. So that can be written as this. Y equal sine inverse x. This can be written as sine y equal x. It's like taking log, taking anti-log. Can you remember? Right? Opposite to that. Okay, so that is how it has been developed, this relationship. So if you differentiate sine y, it becomes as cos y into dy by dx, because we want to differentiate y with respect to x. So that will remain. So ultimately, you can write it as dy by dx is equal 1 over cos y. Now, dy by dx cannot be given in terms of y. Then it becomes as an implicit function. Then what shall we do? We want to bring this in terms of x. For that, we could use the identical relation. Can you remember? Sine square y plus cos square y is equal 1. So from that, cos square y is equal 1 minus sine square y. Can we write like that? It's like earlier identical relation. A couple of minutes ago, we have used it. Then, what is cos y? It is the square root of 1 minus sine square y. Do you all agree? Now, what I am going to do is, I am going to substitute to this dy by dx, which is 1 over cos y. Instead of cos y, I am going to substitute this as square root of 1 minus sine square y. Right? From the question, we know sine y is equal x. Sine y is equal x from the question. So instead of sine y, I am going to substitute the value x. So 1 over square root of 1 minus sine square y. Sine y is x. So sine square y is, somebody is writing on my pad. Who is that? Huh? I can catch you. Don't do foolish things. I can look at the recording and find out who is the person. Don't write it on my pad. This will remain forever now until the lecture over. So 1 over square root of 1 minus, right? Sine square y. So we know sine y is x. So that sine square y is x. So this is my dy by dx. Derivative of y, sine y equal x. You see, this mark will remain. That is what I said. Don't do this kind of foolish thing. Right. Let's say y is equal sine inverse 2x. Can somebody complete it? Sine inverse 2x. How we can write this? Sin y equal to x. Now continue from there. There was a power cut. Let's see. Can you all hear me? Can you all hear me?
Yes, sir.
Yes, sir.
Yeah, suddenly there may be a power cut. Let's see. Yeah. The light has come. Generator has switched on. If you have disconnected, just tell me. Carry on with the question. Sin y is equal to x. Simple way. So this becomes as cos y into dy by dx equal derivative of right side, which is 2. So dy by dx is equal 2 divided by cos y. What is cos y in terms of time? Use the identical relation which I have already used. Sin square y plus cos square y equal 1. How we can write dy by dx can be written as 2 divided by square root of 1 minus sin square y. Same thing. Then dy by dx, we could write it as 2 divided by square root of 1 minus 2x square. So that is equal 2 divided by square root of 1 minus 4x square. Any question? Any question? Right. We will move to further. Let's say another trigonometrical inverse function. Y equal cos inverse x. Cos inverse x. So we can write it as cos y is equal x. Right? Cos y is equal x. So cos y, if you differentiate, it becomes as minus sin y into dy by dx equal 1. So we could say dy by dx is equal minus 1 over sin y. Minus 1 over sin y. So again, we use the same rule, sin square y plus cos square y equal 1. The same identical relation. From that, we could say dy by dx. Instead of sin y, we could substitute 1 over square root of 1 minus, right, cos square. So we know that cos y is equal x. So that is equal minus 1 over square root of 1 minus x square. So that is my answer. Then there's a power failure, something wrong, going and coming. Right? Any questions? Try one more. Y is equal cos inverse 3x. So that is equal cos y is equal 3x. If you take the derivative of cos y, it becomes as minus sin y into dy by dx equal 3. So dy by dx can be written as minus 3 divided by sin y. So this sin y, according to our identical relation, we could say dy by dx could be written as minus 3 by square root of 1 minus cos square. So that is equal minus 3 by square root of 1 minus, instead of cos y, we know 3x. So 3x square. Sorry, 3x square. So that is equal minus 3 by square root of 1 minus 9x square. So this is minus. Clear to everyone? Right, I will show you one more other trigonometrical function. Y equal tan inverse x. Tan y is equal x. What is the derivative of tan y? What is the derivative of tan y? Anyone? What is the derivative of tan y? Just now we discussed sec square y into dy by dx equal 1. So dy by dx is equal 1 over sec square y. So if you continue further, right, how we can write instead of sec square in terms of tan? Anyone? What is the other identical relation I can use it? The relationship between tan and sec we have learned in the second class probably, or first or second class, I can remember. What is the relation between tan and sec? Identical relation. Anyone? Anyone? What is the identical relation between tan and sec? Yeah. Madhavi? Mendis? Nalin? Whoever it is.
1 plus tan square equals to sec cos.
Yes, yes. So we could say 1 plus tan square y equal sec square y, isn't it? This is one of the identical relation. I said at the beginning when we discuss about this identical relation, keep this in mind. Later on we will be using. One we have already seen, that is sine square y plus sec square y is equal 1. That is first one. This is second one. Third one, anyone?
Cot square y plus 1 equals cosec square y.
Yes. Yes. That we are going to use it now, but anyhow, the third identical relation, 1 plus cot square y is equal cosec square y. So this is the other identical relation. These three identical relationships you should remember to solve the problems of inverse functions. Clear? Right, we will continue from this. So instead of sec square x or sec square y, we can write 1 plus tan square y, isn't it? So that I would write it as, coming back to our previous question, dy by dx is equal to 1 over, instead of sec square y, I can write it as right 1 over 1 plus tan square y. So we know what is our tan y. Tan y is x. So that we could say dy by dx is 1 over 1 plus tan, x square. Clear to everyone? Right, we will have some example for homework. Right, you can try this. Y equal sine inverse 3x square. I think some of you are joining for the first time. I cannot tell every day the story. You have been shared with the Google Drive where the recordings have been already uploaded. You can check. You can check with the system analysis. Already the past recordings have been uploaded. Right? These are examples. Huh? You can try this. Sine inverse 4x square. Y equal cos inverse 2x square. Y equal cos inverse x square. Right? These are homework. You can try. Y equal tan inverse x square. Y equal tan inverse 4x square. Right. These two, these are important. These others you can try, which we have not discussed. Y equal cosec in the same way, right? 2x. Y equal cot 3x. Cot inverse. We didn't do this, but we can. If you differentiate that, that I have already given. To differentiate cosec, what is the answer? To differentiate cot, what is the answer? So that based on that, you can complete it. Yeah. Any questions on inverse functions? Any questions on inverse functions? If not, we will break. We'll have a break and come back. I'm going to remove these notes because already these lines are disturbing me. These two lines, so that I want to get a fresh one. I want to close it. Right? Okay. We'll have a break afterwards.
Static අපි download කරලා
Okay, we can continue. Any questions on inverse functions? Differentiation of inverse functions. Today also you have received the link. Again, those who are joined for the first time can make a those who have joined for the first time, still you can get the link, get the lectures in the link provided. Right. Any questions? Let's look at higher order derivatives. Higher order derivatives. Right? Higher order derivatives. Let's say y is a function of x. We'll take an example, 3x to the power 4 plus 8x plus 3. Let's take a function, right? Your first derivative, dy by dx, given as f dash x is equal, simply you differentiate it. Can you all hear me?
Yes, sir, we can.
Right.
Yes, sir.
So your first derivative is you differentiate directly. That is 12x to the power 3 plus 16x. So this is called as first. This is first order derivative. Then we go for the d square y by dx square. This is called as second order derivative. Again, you do differentiate that function. That is 36x square plus 6. So this is called as second order derivative. Right? Then you have third order derivative, which is called as f triple dash is equal 72x. Right? Here, the last one, this is called as fourth order derivative. 72. This is your fourth order derivative. Fourth order derivative. So what is the next order derivative? What is the
Zero.
next one? 0. So this particular function is having maximum of 4 order derivatives. So that we can find out what is the highest power that it has. It can go with fourth order maximum. Right? So the first order derivative, second order derivative, third order derivative, and so on. There are some applications on this. That is why we are talking about it. Right. Another example. Let's say y equal sine x. Can you find out the first order, second order, third order, fourth order, fifth order, and so on? I will give you first one. Dy by dx, which is f dash x, is equal cos x. That is your first order. Go for the second order. What is your second order derivative? I will simply put f double dash. Anyone? You have learned. Second order derivative.
Minus sin x.
Pardon?
Minus sin x.
Minus sin x, yes. Minus sin x. What is the third order derivative? Anyone? Third order? When you differentiate sin x, it becomes as cos x. When you differentiate minus sin x, it becomes as minus cos x. What is the fourth order? Derivative?
Sin x.
Sin x. Right. Now you see, we have come to the point where we started. What is here? Then if you differentiate further, it will go on a cycle, right? Anybody? Yeah, any idea? Why it is? Because if you look at the angle, measuring angle, it goes like this, isn't it? Cos sine. So this is quadrants. Can you remember we talked about different quadrants, right? So here, if you take sine x or sine theta, then when it goes to the derivative, this is second, third, fourth And again, it comes to the fourth one, right? The first derivative, second derivative, third derivative, fourth derivative, it comes to the same position as earlier. You could see here, right? This is, I have put it here. This is 90 degrees, this is 100. This is how it works for the sine. Doesn't matter whether it is sine or cos or whatever. If it is in cos, the same story, right? So actually, what we try to say is the first derivative, try to tell you what is the slope after the turning point. So in my case, here the turning point is this. This is the turning point. After the turning point, the slope is given by the next derivative, second derivative. So after the turning point, this is the turning point. So after that, after this, these are the turning points. So after that, each derivative will give the slope of the curve. So that is the principle. We are going to use this information for our application, right? So these derivatives, first derivative, second derivative, third derivative, will give you some indication of the curve, I mean, slope of the curve where after each and every turning points, right? Okay, now we will move further. That is on application of derivatives. Application of derivatives. Application of derivatives. Let's say, what is the application of derivative? Suppose if you have a function, right? Let's say this is a curve function, not a linear function, curve function. Suppose give me, I have to draw something and then first I will draw it. Right. Let's take y is a continuous function, which is given as y equal fx. Red color is the function, I mean curve. Y is the continuous function, right? At point A, I'm drawing a tangent line to point A, where it touches with the coordinate of x0 and y0, and it makes an angle with x-axis theta. The point P is the intersecting point at the x-axis. Then we could say the slope of the tangent or the straight line AB can be given as tan theta. From our trigonometrical functions, we talked about this, right? So this tan theta is same as my derivative, first derivative. Tan theta is equal to my first derivative, right? So this is the first application that we are going to use, right? With that respect, find the slope of the tangent to the curve tangent to the curve y equal x square at the point coordinate 2 and 4. At the coordinate 2 and 4. So we were asked to find out the slope of the tangent to the curve x square at the point 2 and 4. So in other terms, in a simple, if you plot it, what is the question, right? So I have a curve which is like this. So it has been given as y equal x square. So that is my function, right? So I have been asked the slope of the tangent similar to the earlier one, right? Let's say this is the slope of the tangent. Blue color is the slope of, the tangent line. So this tangent line, actually, right? This is my point. So the tangent line at the point, what is the coordinate? 2 and already 2 and 4 because the point has been given. Here, what is the slope? Find the slope of the tangent to the curve y equal x square. The function has been given. So at point, this particular point, what is my slope? So again, I can put it as A. At point A, what is the slope? Again, according to the same principle that I have gone through. So I want to find out the slope at A. Do you all agree? Slope at A is the slope of AB. Right? If you draw a tangent, that is the slope at A. So that is given by the derivative of the function. So we want to find out dy by dx. So we know that y is equal x square. So dy by dx, that is your first derivative, is equal to x. So that is the slope of that particular curve at any point. Slope of the curve at any point. So I want to find out the slope exactly at when x equal 2. So that is equal 2 into 2. So that is 4. So tan theta is actually, right? We can find out if you want in terms of theta or in terms of this is the slope gradient. So this is one of the application, right? For example, let's say I have given a task to, let's say my function, any function, growth of a population or height study of a plant community, right? So height is something like this of a plant community. I want to find out, let's say this is the age, this is height. I want to find out, let's say this is a function, y is equal given as fx. I want to find out exactly what is the slope at, let's say, at a particular age, right? We don't need to worry about height, especially what is the age. Let's say age is given as in days. plants. Let's say this is a maize plant. Maize plant, it is a continuous function. So I want to find out what is the exact height at the 60 days. 60 days after transplanting or after planting. Right? After 60 days, what is the exact growth rate? Right. After 60 days after planting, I want to find out the exact growth rate. Don't forget this. I'm talking about growth rate, huh? Rate of change. How to find out? If you have a function, take the first derivative because it has been given in terms of function, any function, any mathematical equation, because we already defined mathematical equation which try to equalize the left side and the right side, which is called as function or equations, right? Right? So if you take the first derivative, then substitute x value with 60. Substitute x value with 60, and that is your right. For example, let's say I have a growth function. Let's say height, height in 100 and height in centimeter, height in centimeter, age in days, right? Height in centimeter, age in days. So this is my function, whatever the function. This is the function, right? Y is height, age is t. Right? How to find out this? What is the derivative of this dy by dx? Anyone? How to differentiate this? Anyone? How to differentiate? You'll have to differentiate. If you don't differentiate, you lost it. You'll have to find out the first derivative of this function. Right? Once you differentiate this function, you substitute the value. When t is equal 60. Instead of t, you substitute the value. Then you will get the growth rate of height growth rate. Right. So don't ask how to differentiate. You find out how to differentiate this. Now you are expert on differentiation. Try to apply it. Right? Right. The second application. This is also one important aspect. Before that, I will draw a diagram. right? I'm taking a few points there. Point A, point B, point C, point D, and so on. Okay? Look at very carefully. This is another application that we directly bring involvement of derivatives, right? What is the slope at B, C, and D? What is the slope at B, D, and B, C, and D? Anyone?
Zero.
Zero. Why? You are
Parallel
right.
matrices.
Yeah, you are right. If you take the slope at B, C, and D, if you draw the tangent line, basically, right? If you draw the tangent line, right? If you take the tan theta, theta is 0. Do you all agree? Theta is 0. So that tan theta is 0. Right? So the slope at B, C, and D is 0. So B, C, and D are important points in this curve. How do you call these points?
Turning point.
Turning points.
In this curve, yes? Somebody said already, yes? Repeat it.
Turning points.
Turning points, okay? So here we have a couple of turning points. So at turning points, slope is equal to C, right? So that is first thing that you realize. Right, now I'm going to make a tour, right? From A to C. I hope everyone has drawn this, right? A to C. I'm going to make a tour from A to C. First, I want to make from A to B. Then later we will move from B to C. Right, when you move from A to B, what do you think about the theta? What do you think about the theta? What is the range of theta value if you move from A to B? If you draw any tangent, for example, we are drawing tangent like this, any tangent, huh? Like this, any tangent. Likewise, we draw the tangent, right? So these are angle, theta. So what do you say about this theta? Value of this theta.
Getting reduced.
Pardon?
It getting reduced.
Yeah, rather than reducing, tell me what is the range of these theta values? We learn already little now in trigonometry. What is the range of this theta value could be? In between what?
90 to 0.
Okay, so we could say the theta is actually less than 90 degree. Okay, theta is less than 90 degree. Do you all agree with that? Right. So if theta is 90 degree, less than 90 degree, what about tan theta? Is it positive or negative? Which quadrant are we talking about?
Positive.
Positive. Which quadrant is that? We learned this.
First quarter.
First quadrant. So if it is first quadrant, theta is, tan theta is positive because in first quadrant all are positive. Right. So this is positive. Tan theta is positive. If tan theta is positive, earlier we said tan theta is equal to f dash x. So that we could say f dash x is greater than 0. F dash x is greater than 0. We are understanding the principles now. Right, let's talk about the second one. At B, we already said our slope is 0. Now we will move from B to C. B to C. So again, we are drawing tangent in this direction. This is one, this is another one, etc., etc. Right? So you can draw the tangents. So this is the angle. Sorry. This is the angle, theta. Now we are talking about moving from B to C. What do you think about the theta? What is the range of theta? Anybody? Anyone? What is the range of theta?
$90 to $180.
90 to 180, okay. So that means it is greater than 90, isn't it? If it is greater than 90, which quadrant it is falling?
Second quarter.
Second quadrant. In second quadrant, how tan theta behaves?
Minus.
Yeah, negative value. Then if it is so, your derivative will be less than 0. So this is the criteria that we use. Anybody has confusions or clarifications to be asked? Very important, huh? Because application, I said, these are the second part of our questions that is going to be come in the final exam. So I don't ask solve this equation and so on. We give a example, real world example, right? Like this. This is a real world example in plant science. This is a function. Find out what is the exact growth rate or height growth rate at a particular point. This is what we need. This is the application. This is not mathematics. It's a combined with mathematics with the application, right? So without knowing how to find out, then you are in trouble. So this is how the questions going to be in your final exam. Right? I will talk about few others. Right. So these are guidelines that you should keep in mind. These two are guidelines. As you all know, at B, which is we call as TP, turning point, my first derivative is equal to 0. Tan theta is equal to 0. Is it clear to everyone? Clear to everyone? Yes. Right. Keep this as a Bible or Quran or Bhagavad Gita or Mahavansa or whatever it is. This is how it could be defined, right? Keep it in mind. So now this is the base foundation. Then we are going to see the application, right? Let's say I have two situations of a curve, right? I have two situations of a curve, right? Right? So one situation is this. Another situation is this of a function. So how do you call this particular point which I have marked in this function? How do you call these the points respective to y value? Yeah. How do you call these functions? I mean, this situation. Anyone?
Maximum and minimum.
Yeah.
Maximum by value and minimum by value.
Yes, yes. So this is in terms of y. First one is a maximum, isn't it? Second one in terms of y, it is minimum. Now this the above phenomena that we have already discussed can be used to find out in a curve where the maximum is, where the minimum is. Right? Where the maximum is, where the minimum is. Right? Right. Take this to information. If your first derivative, when you substitute the value with x naught is equal 0, and your second derivative is equal, less than 0, then I'll explain, write down first. Then the x naught is a x naught is a maximum. Your first derivative is 0. Your first derivative is 0 at x naught. This is my x naught. Your first derivative is 0. That means it is a turning point. You take the second derivative is less than 0. So look at here, this is second derivative, gives the slope of after the turning point. So the slope of after the turning point is less than 0. Can you remember our rule earlier we discussed? Negative slope, right? Tan theta is negative. So f dash is negative. So if it is negative, it is less than 0. Then we could say that x naught is going to be a maximum point. Similarly, the second rule is same as the earlier one. If my x naught is equal 0 and my second derivative is greater than 0, then my x naught is a minimum So this is my x naught. So x naught is the turning point where my first derivative is equal 0. And find out the second derivative of that function, which is greater than 0. So that it is a minimum point. So these two phrases you should remember in any examples. Why I'm saying is, for example, let's say, what is the application of this? I'll take one by one. Let's say meteorological rainfall, amount of rainfall.
Excuse me, sir.
Yeah.
I have a question
Yeah.
regarding the previous one. Can you please explain how it's going to, it's getting lower than 0, sir?
Lower than 0 means?
In the first statement.
You see here?
No, sir, in the below graph.
Yeah, because below one is based on, all are based on this.
Yes.
Right? Because I already showed you, if you move from B to C, my slope is going to be negative, isn't it? If I move from B to C, that slope is negative. If the slope is negative, what is the position of B? For example, if the slope is negative, what is the position of B? Because first derivative is given by the turning point, which is equal 0. The second derivative indicating your slope after the turning point. If it is 0, sorry, less than 0, right, after the turning point, then it is a maximum point. In the second case, let's say I move from C to D. Already I said A to B or C to D, right? If you move from C to D, right, at C, we know that slope is, right, equal 0. At C, slope is 0. When you move along C to D, what do you think about the slope? Yeah, slope is more than 0. That is my second derivative. So from 0 to more than 0, if you move it, then that is identified as a minimum point.
Okay.
Right? So maximum point and the minimum point. How to identify these 2 points based on these 2 principles. These 2 principles. Identifying the minimum and the maximum using these 2 principles. Right? So here, that is what I said here. The first one, if your first derivative is 0, that means it is a turning point. Right? If it is not a turning point, the derivative will not be 0. So here, if it is a derivative is 0, that is definitely a turning point. So we want to identify whether that turning point is a maximum point or minimum point. Look at the second derivative. Second derivative shows, because already I mentioned, the second derivative gives the slope after the turning point. After the turning point. Second derivative gives the slope after the turning point. If the slope is going to be less than 0 after the turning point, so that is coming down. So that means the earlier point that we spoke about should be a maximum point. Right? Similarly, if you take the second example, f dash x naught is equal 0, that means definitely it's a turning point. It's a turning point. Now, after turning point, you see how they behave with the slope. So we give the slope after the turning point using the second derivative. So second derivative shows the value is positive. If the value is positive, definitely it goes upward, isn't it? Not downward. So if it is going upward, so we could say my original point that I was discussing is a minimum point. From the lower point only you can go up. So that is how we identify these 2 points. Yeah? Yeah, any questions? Right. Let's say here we have months up to 12 months as an example. Amount of rainfall. Do you think the rainfall is same or different in different months in Sri Lanka? Let's say in Sri Lanka dry zone. What do you think? Different, yeah. So we have a, how do you call the rainfall pattern of Sri Lanka? Agriculture students should have gone through it, at least.
Monsoon.
No, monsoon is the way that we receive the rain. But I am talking about by looking at the distribution of rain. How do you call the distribution?
Yalamaha.
No, it shows some kind of pattern. How do you call? Yeah, it is called as bimodal pattern. Something like this. Don't worry about this month and all. Huh? Don't worry about this month and all. Month can be shifted here and there. So it shows a pattern like this. Or sometimes people draw it a little bit different way. Something else. So this is mainly, I'm talking about dry zone. Maha, right? I mean, this is the Maha season. This is usually Yala season. Those are intermonsoon seasons, the other seasons, right? Now we can find out what is the, in this particular example, what is the maximum peak? What is the minimum peak? So there are 2 peaks actually, bimodal, that is what we call it as. So this is another application where we apply. For that, we should have or we should know the function. Right? I'm just listing out some of the functions. Another one, maybe in animal science, milk production of a cow during the lactation period. So lactation, maybe the cow milk goes like this, lactation, right? So what is the peak? We can find out. So usually they milk maximum 300 days from the calving, giving the birth. So what is the maximum milk that has been obtained, or during which period of the lactation period that maximum milk is obtained? So that is a turning point, isn't it? That is a turning point. It could be maximum or minimum. Another example, let's say paddy production. Not paddy, onion in Dambulla area. So they cultivate onion almost every month. If you go to Dambulla area, they cultivate almost every month bee onion. So how the production is? How the production is? This is month. This is yield, right? So in some months the production is low, then suddenly goes down, then goes up, then comes down, then stay. So here I can identify 2 points. One point is in which month that the maximum production received or cultivated in the Dambulla area. What is the minimum production? Right? So we can find out these two if the function has been given, right, on a mathematical term. So these are some of the applications that I'm talking about, right? So in agriculture, we can talk about the data, maybe, let's say coconut or paddy or anything we can. So this is years, this is yield, either coconut or tea, rubber, right? For any commodity, any raw material, any plantations that we can use. So starting from, let's say I have data from 1970, right? So there may be functions like this. So I want to find out the turning points. Isn't it? Exactly the turning points. If you know the graph, then we can find out the turning points. Suppose if you don't know the graph, if you have only the function, how to find out the turning points using the mathematical equation, right? So that is the application of this turning points. Right, we will take an example and do it, right? We'll find out the turning points, not in terms of direct application, but in the coordinates, right? Let's take, I have given an example. Let's say, example, my function is equal 1 over 6 into 2x to the power 3 minus 3x square minus 12x plus 12. So this is my function. Right. Can you remember when I talked about functions? By looking at the function, we can decide how many turning points are there. Maybe first lecture, equations, when I talked about equations, linear equations, quadratic equations, cubic equations, I mentioned about by looking at the structure of the equation, you can simply say how many turning points are there. Can somebody tell me, recall how we decide the number of turning points by looking at the equation?
N minus.
Yeah?
N
N minus 1. What is this N?
Maximum power.
Maximum order, maximum power. So here, what is the maximum power X has?
3.
3. So 3 minus 1 is 2. So at least 2 turning points are there in this example. We don't know whether these are 2 minimum points or 2 maximum points. Could be. I don't know. We don't know. Or maybe one could be minimum and one could be maximum. Definitely, usually that is how it happens. One could be maximum, one could be minimum. Right, now we want to solve this. First, how to solve it? Now we want to get the first derivative. What is the first derivative? First derivative. This is a constant, 1 over 6, it's remain. But in the first derivative, 6 x square. Now you'll have to be expert on differentiating, otherwise in trouble. So this is my first step. So here 6 can be cancelled off. So my first derivative is equal x square minus x minus 2. Right? So I have got the first derivative. What is next? Anyone? What is next? What does it say? At turning point, your first derivative, value of the first derivative is equal to 0. Do you all agree? So I would say f dash x, which is x square minus x minus 2, is going to be equal to 0. My first turning point will have a derivative value, which is slope is equal to 0. Now we will have to solve this. Now we need the quadratic equation to be solved through factorizing. Can you remember factorizing is coming here? Now you cannot use formulas here. If you want, you can use the formula, but factorizing, find out what are the x values. There will be 2 x values. Find out what are these 2 x values. And tell me what are these x values. The values, huh? Sometimes your values may be correct, wrong.
X equals -1 and x equals +2.
Yes. We will have 2 values of x. One is x equal 2. The other one is x equal -1. Right? So that is why you will have to be careful. X minus 2 into x plus 1 is equal 0. This is how you can factorize this in simple form. X square minus x, then you have -2. So from this, we could say one answer is x equal 2, the other answer is x equal -1. We found that means at 2 places it is turning. When x equal 1, -1, and x equal 2. But we don't know whether these are maximum or minimum points. How to find out the maximum and minimum? Anyone? Yes? How to find out the maximum and minimum point? We'll have to get the second derivative for that. What is the second derivative, anyone? You continue your first derivative differentiating once again.
It's -1.
Yeah?
2x minus 1.
2x minus 1. Now you should be expert on differentiate. Right, now when x equal 2, apply to this function. So that is 4 minus 1, which is 3, which is greater than 0. So what can you say about x equal to? Is it a minimum point or maximum point?
Minimum point.
So this is going to be minimum point. When x equal to, it is going to be minimum point. Let's say minus x equal minus 1. So your derivative, right? If you substitute, that is 2 into, right? 2 into minus 1 minus. So that is equal 2 into minus 1 minus 1. Minus 2 minus 1. So that is minus 3, which is less than 0. So this is the maximum point. So that is how we find out the maximum and minimum. Now when you say these 2 points, here we have x coordinate. We want to give y coordinate also. Only we gave x coordinate, x equal 2, x equal minus 1. Now we'll have to give in terms of y coordinate also. So when x equal 2, what is the y? For that, we'll have to find out the value from the original equation. When x equal 2, we find out the value for y. We substitute the value 2 into 2 to the power 3 minus 3 into 2 to the power 2. So minus 12 into 2 plus 12. Can you work it out? What is the value? Similarly, when x equal minus 1, you find out the y value. That is equal 1 over 6 into 2 into minus 1 to the power 3 minus 3 into minus 1 to the power 2 minus 12 into minus 1 plus 12. Can you find out the answer for y value when x equal 2 and x equal? Even if you keep it on fractions, that is fine. You don't need to solve it. If you keep it fraction, that is fine. Find out the y values. Anyone? Y values?
$15.33 and 14.16.
Which one is 15? When x equal to, what is the value?
Yes.
When the x equal to, what is the value?
14.16.
14 by?
14.16.
Oh, something wrong. Check correctly. Any other answers?
4
4 by 3, sir.
4 by 3. Which one?
When x equal to, it is minus 4 by 3.
Okay. When x equal,
Minus 1, that is 19 by 6.
y is minus 4 by 3. When x equal minus 1, what is the value of y?
19 by 6.
19 by 6. Whether it is a plus or minus?
Plus.
Plus. So this is, when you give it, you'll have to give with the coordinate, x coordinate and y coordinate. So this is a minimum point, as we said, right? This is a maximum point. Any questions? Right. Now, we will do another example. Everyone, you come up with the answer. Another example, y is equal. In a similar way, you find out coordinate of the turning points and tell whether they are minimum or maximum. Function of x is given as 1 over 9 into x to the power 3 plus 3x square minus 9x minus 30. Can you work it out, everyone? First step, find out the derivative. How many turning points? Again, here, 2 turning points. First, give me the derivative. What is your derivative? First derivative. Final answer for the first derivative. It's easy, isn't it? First derivative is 1 over 9 into 3x square plus 6x minus 9. This is your first derivative. So we could further say 1 over, if you divide by 3, 1 over 3 into x square plus 2x minus 3. Right? Can you do factorizing only for those 1 over 3 into factorize? Any comments for the factorizing?
X minus 1 and X plus 3. So X is
Plus
plus 1
3.
and X is minus 3.
It's plus 3 and
No, sir, the final one I got as X minus 1 and X plus 3.
okay. So here from here also we can start. We can say, I mean, when you factorize this x plus 3, x minus 1, right? So one answer is 1 over 3, x plus 3 is equal to 0. The other answer is 1. 3x minus 1 is equal to 0, right? So that is how it works. So that here in one case you could say 3x plus 9 equals 0. Okay, if you multiply by 3, okay, so 3x plus 9, so 3x is equal 9, so that x equal 3. So this is x equal minus 3, right? Minus. Okay, because then similarly, 3x minus 1 is sorry, minus 3 is equal to 0. Okay, multiply by 3, 3x minus 3 is equal to 0. So 3x equal 3. So x equal. So you have two coordinates, x and y. Now find out the y coordinates first. Then tell about the minimum and the maximum. Whatever the step that you like to take. Simply you substitute the y value, I mean x values on the equation, original equation, not on the derivatives. Substitute on the original equation, then you get it.
So when x equals minus 3, y equals 14 by 9.
X equal?
When x equals minus 3, y equals 14 by 9.
Okay. Any other answers? Right. What about the second one?
Y equals minus 2.
Minus 2.
Yes.
Okay. Let me check my answers. Yeah, answers are correct. Now you can get the which one is minimum and which one is maximum coordinates. Anyone? So one coordinate is x equal minus 3 and y equal 14 by 9. The other one is x equal 1 and y equal minus 2. So now we want to find out which one is minimum, which one is maximum. Anyone? Take the second derivative. So my first derivative is already there. Take the second derivative. So f double dash x is equal 0. So my first derivative is this. So go for the second derivative. That is equal 1 over 3, 2x plus 2. Now, when x equal minus 3, what is the second derivative? So, when x equal minus 3, what is the second derivative?
Minus 4 by 3.
Minus 4 by 3. So, minus 4 by 3, which is less than 0. So, whether it is a minimum point or maximum? It's a maximum point, isn't it? When x equal 1, what is the second derivative value? Substitute the value, which will become as 4 by 3, which is greater than 0. So we could say, these 2 points, right? From the evidence, this is a maximum point. This is minimum.
So without going to the second derivative, by looking the y value, can we tell the maximum minimum value?
No, we cannot say. Because y can be like this, right? That we cannot do it. Because here, let's say, it doesn't matter whether send that. So here, we can have, you said the y value is minus, right? So maybe I'll take it as right, minus y values plus y values. So in this case, sometimes it's like this, right? So this is minimum and maximum, right? Could be other way also. Wrong. Could be this way. 2 minus values, right? Because we are not sure. Right? We'll have to prove it using our second derivative, right? Generally, you can, by looking at minus value, you can say, but we'll have to prove it. So everything is with some kind of proveness, right? So that by looking at the y value, don't tell it. Even though if you can tell it, don't tell it, but prove it. In the exam, we are looking for your proveness, right? Right. That finishes our lectures today. However, we have one quiz left. Right? So, right. This is the quiz. Find out the coordinate. Find the coordinates and the radius of the following circle equation. Find the coordinates and the radius of the following equation. This is the equation: 2x square plus 2y square plus 10x minus 16y minus 40 equals 0. So this is the equation. Find out the answer. Answer everyone. Write it in one as a one answer. Don't put it in twice or thrice. So you will be losing marks for that. Write it in one, because first find out the coordinates, then you have already, I said this. Don't type it twice, thrice, because we'll have to look at marks at several locations. Find it, the coordinates, and in one shot you give the answer.
Hello, sir.
Yeah.
Sir, could you please, can you read the question again?
So this is the question. Find out the coordinate of the center and the radius of the center.
Thank you, sir. Okay, sir. Thank you.
You have 2 more minutes. Right, I think the time is up. I'm going to wind it up. Tomorrow we are starting at 1 o'clock. Huh? Don't forget, we are starting at 1 p.m. tomorrow. Okay, see you. Bye.